All right, good morning, everybody, and welcome. Let's just change the lighting here so we can get a better look at what I look like. So welcome to everyone. This is the Gen low voltage, the EU version 6 kilowatt working modes introduction with LuxPower. I'm your host, Andy. And today we're going to go through these working modes. It's a brand new machine for South Africa. We don't have the machine on sale yet. Can everybody see my screen? Just give me a thumbs up if you can see the screen sharing. Screen sharing is good and everybody's good. All right, the visuals and audio is good. Okay, guys, so what we're going to do today is we're going to go through the Gen 6 low voltage. It's the European version. It's a 6 kilowatts, and we're going to do the working modes introduction. All right, so the contents of today's training is going to be the installation, and then as well as the introduction to the different application scenarios. In our previous training session, we went through the topology of the machine. We had a look at what the machine looks like and what its capabilities are. So if there are any questions that you have, you're more than welcome to type them in the chat column. I have muted all of the microphones, so you can request either to, if you want to post a question, you can ask to have your microphone unmuted. Alternatively, just post the question in the chat group, and in the last 5 minutes of the training session, I will go through all of the questions and I'll answer them to the best of my capabilities. All right, so when we have a look here on this particular screen, you'll see that we've got the bottom of the machine exposed, and we are using a stack of high-NA batteries, or LuxPower batteries, as they will be rebranded in some countries. So just to refresh on the topology of the machine, this is typically what it looks like underneath. It still has the black skirt. Here is the skirt, but this time the skirt is not screwed on. It's simply a clip-on, which makes it a lot more easier to fit. And also the reason why we call this machine the Gen LXP is because it has this extra generator port input. Remember, the old LXP5 didn't come with the Gen port, and you had to tee it in on the AC side. But now the machine has a generator, a dedicated Gen port, which we're going to use for three particular applications. We can either use it as a generator port, we can use it as a smart load port, where it takes AC coupling, or it can take, we can use it as an auxiliary output port, but we're going to go through those applications a little bit later. So in this particular setup here, we've got the bottom of the inverter showing. So there you've got your grid input, you've got your generator input, and you've got the EPS output. This here is your interface block, and I always advise and recommend installers that even though you're installing this machine indoors, it's very important to fit this shroud over the interface board, because it comes with a big grommet inside here, and you can pull out the plugs to let your cabling through, depending on what cabling you're going to put through there. And the reason we do that is because this machine is an IP65 rated machine, and the only way that anything can get inside the machine is if they enter through the slots between the board and the chassis here. So it's very important that this cover or this shroud gets put on. Okay, so there we have the dongle. This here is a DC switch. It's a isolator for a rotary switch for your PV, and then you've got your two strings of PV coming, PV1 and PV2, and then here obviously is the battery terminal. This particular screen here, we're talking about the battery connection. So the battery connection goes there. There's your positive connection via the bus bar if you're using more than one inverter, and then obviously here's the negative. On our particular installation here, we're using the high-NA or LuxPower batteries. This is the High 5, and the High 5 is the only battery that we in our stable that uses the dip switch settings, where you have to particularly set the dip. Our generations which came out after that, being the Power Gem, the Power Gem Plus, and even the Power Stack, and also the battery that comes with the EcoBeast, it's addressing on the dip side, so we don't have to worry about that. So it's only the existing high-NA High 5s or the Lux High 5 that will use the dip settings. Okay, so make sure, obviously, that the selected battery module is on the compatible list. We often get that in the support center. Regard will ask us, is this battery or is that battery compatible? Only the batteries that are on the list that we've provided you, you can ask us for the list, we can give it to you. Only those batteries are batteries that we guarantee will work with our inverter. If you buy a battery that's either rebranded or it's not, or it's an OEM battery, you can, and it comes with a BMS, you would have to check with your supplier to see what their CAN bus or their RS485 Modbus protocols are, and then match it up with ours, and then you can test it either on the standard lithium or one of the other settings. But we haven't done any, if it's not on our list, we haven't done any collaborations with them, nor have we done any testing. And at this stage, we're not going to be adding any additional batteries to the list, unless, of course, it's a high volume seller in a particular region, and we set aside some time for interviews. Okay, so make sure that your selected battery is on the list. Make sure that the pinout configuration is correct for both the battery and the inverter side. Remember that our CAN bus is on 4 and 5, and our RS485 Modbus is on pin 1 and 2. So whichever battery you're using, just make sure that you're using is routed in the correct manner. Okay, then make sure the settings are correct on the battery side. So for the Hi5, obviously, this is an example of the layout. For Dynes, it'll obviously be different. Pylon is different, and so forth. So just make sure that for your battery of choice, you always make sure that the settings are correct, as well as the cable. If those things are correct and you've chosen the correct battery on the list, then there shouldn't be a problem with the communication. All right, and then make sure that the battery brand option on both the battery and the inverter side are correct. If you're using an incompatible lithium battery, in other words, the battery is still a lithium battery, but it's not on our list, then we recommend that you use it in lead acid mode. Now, lead acid mode is just a phrase, it's a term, okay? It doesn't literally mean that you're using lead acid batteries like you get in an old car. It simply means that we are going to be controlling the battery charging and discharging via voltage control. Okay, so the SOC will be a calculation; it's never accurate, and you'll be working particularly with the voltage control. All right, so on the PV connection, most of you guys are very familiar with our brands or our products across the range. And you will know that our machines have got, all of our machines have got, besides the 12 kilowatt, they've got a dual MPPT, so they've got 2 inputs. And you can string the PV, you can either connect them as 2 separate strings. In other words, where you have in this section here, you've got your string A and your string B, and they're going to PV1 and PV2 independently. Or you can put up your 2 strings on the roof, and then you can combine them where you're connecting 2 strings in series, and then you parallel the strings like that we've done here, and you're going to bring it in, but you're going to bridge out. Once you bring it in, you're going to, in other words, here you can see from the roof down, there's only 1 set of cables coming down, whereas in this scenario, you've got 2 sets coming down. In this particular set, they've only got 1 set of cables coming down, but inside the PV combiner, they bridge it out and they bring the positives into PV1 and PV2, as well as the negative into PV1 and PV2. And then on your setup, you're going to select that you have brought down either 2 separate strings or 2 strings on the same MPPT input. However, you've got to make sure that, number 1, that the open circuit voltage, or the VOC of the PV input, in other words, the complete string input, is less than the max input voltage of 550 volts. Okay, and this is regardless of whether you've done it in this configuration or the configuration. We cannot exceed this voltage. All right, and then make sure that you select a solar panel that has the current max limit less than 17 amps. In other words, the IMP, maximum power. So I is current and MP is the maximum power at 17 amps, to ensure that the tracking of at the maximum power point of the string is not exceeded. And then we always recommend that you fuse and connect a circuit breaker in your string, which will be here before it goes into the inverter. Make sure that the fuse and the breaker are rated, and specifically we want to go at 1.2 times the maximum current. Okay, so if the current is 17 amps, then you want to go to 1.2 times the maximum current. So we typically sell either, if it's on the smaller panels, we'll go with a 15 amp fuse. And on the bigger ones, we'll go with the 20 amp fuse. And then obviously your breaker needs to be rated either for 600 volts or 1000 volts, depending on what size, I mean, here at 550, it's going to be quite close, but on the bigger machines, you're going to go for a 1000 volt breaker that is rated either at 15 or 20 amps, depending. All right, and then here we've got a big warning: do not ground any of the PV polarities. In other words, do not take PV positive or PV negative to earth, and also do not reverse the PV connection. So in other words, don't come in here with the PV turned around. All right. Some guys in a bigger installation, they will actually put diodes on the strings that the power can only flow in one direction. Okay, so our grid connection, as we mentioned earlier on in the very first slide, we have 3 terminals underneath, connection points underneath the inverter. And the first one here is marked grid. And we supply the Gen 6 with all of the quick coupler plugs. And the plugs do not interchange between these ports. In other words, the grid plug will fit on here and on here only. The Gen or auxiliary plug will fit on here, and the EPS plug will fit here, and you cannot swap them around. The main thing for you to make sure is that when you wire up the plug, that you wire the live and the neutral to the correct terminal ports, as well as the earth. And earthing obviously is very important. Even if you do not have utility earth coming in, you're going to have to create your own earthing at the installation according to the stands code. All right, so grid connection, we're going to bring in the grid here, and remember that this machine is supplied with a CT. Your grid live comes through the CT, and the arrow always points in the direction from grid to the machine, right? So the supply will run through there. With grid CT connection, both the load consumption and the EPS side and the grid side can be compensated. All right, but we're going to go through that in the working mode. For your cables and your breaker selection, remember that this machine is a 6 kilowatt machine on the inverter side, but it is allowed to have bypass power of up to 8 kilowatts. So if you are running loads at 6 kilowatts and you can charge up to 3 kilowatts, then it simply means that your breaker on the incoming side must be able to carry load and charge the battery at the same time. We recommend that you go for a breaker that is rated for that. Most domestic installations in South Africa come typically with a 3 amp connection, but obviously for an 8 kilowatt, you can probably go down to 40 amps. But just remember that you don't want, if you don't want nuisance tripping of the breaker, then you would rate the breaker accordingly. All right, so the breaker must be rated 63 amps maximum and 230 volts AC. And also the cable requirement here on our training supplement, we've got the American wire gauge size of 8 to 6 to 8 American wire gauge, or in English term, that is 9 to 14 millimeters squared. And that is the cross section of the copper inside the cable. Right, the grid CT connection, just remember that the location of the CT should be installed at the live. Here we've got it on the live incoming of the grid input side, and the direction of the arrow, which is stamped onto the CT, must go in the direction from the grid to the inverter. All right, and then the plug of this goes into here where it says CT and meter on this RS485 meter port. Underneath the machine on the interface port, it goes in there. It's very clearly marked. The meter itself that we supply comes with a 5-meter cable, but inside the pack we also supply you with a connection grommet, so you can cut the cable and you can lengthen it. This wire here only has 2 cables inside there, or 2 wires inside. The cable is 2 wires, and they're color coded, so you're simply going to join them and connect up the wires according to the color. All right, if you don't do that, then obviously we're not going to get an accurate reading on the machine itself. And excuse me for yawning. On all of our LXP range and even the SNA range, if you're going to enable using the CT on the SNA, but on the LXP, certainly the CT is a critical part of the installation. You have to use it. All right, so now we're going to have a look at the independent generator port, which is here underneath the machine. Now remember that this even though it's marked as a generator port, we sell it and we market it as a smart load port. And what do we mean by that? The smart load means that you can either have it as an auxiliary output, which is here on the smart load side. You can have it, you can use it as an AC coupling port where you have already an existing grid-tied inverter on your client's property, and you simply want to use that in conjunction with your battery, the energy storing capacity of the Gen 6. So then you will plug the output of your grid-tied inverter will go in here. It'll go into the gen port, or alternatively, you can use a dedicated generator to go in there. Now remember that this port can only be used as one of the following. You cannot use all three inside there. So just remember that if you're using it as a generator port, it has to be used as a generator port for you. Here we've actually gone through it. So the smart energy management means that the independent generator port automatically stops and starts the generator. And it is based on real-time energy needs. You can retrofit it for the existing on-grid solar system, which is the AC coupling, or you can push surplus energy generated to be consumed by the smart load. So basically what you can do here is, I'll just give you a typical example. In South Africa, we have homes that may have underfloor heating, it might have a pool pump and stuff like that, that you don't want to put on the EPS output. You can connect those loads to the generator port and enable the smart load port. What will happen in a case like that is that any power that is generated by solar will go first to EPS load, it'll go to battery charging, and then the surplus power will go via the generator port to the smart load port before any exports are taking place. And remember, our exports go out of the grid port, it'll go to the non-essential side, and if you've enabled export to grid, then it'll go there. But basically, what we're telling you is that any surplus power before it gets exported to the non-essential side or to the grid will always be fed to the generator, to the smart load port. And remember that if you're using a 6 kilowatt or a 10 kilowatt or a 12 kilowatt machine, and you are using the smart load port or the auxiliary output, that your EPS output and your smart load output combined must be equal to or less than the capacity of the inverter. So in the case of the 6 kilowatt, the output of these two combined, if you're using it as an auxiliary port, combined must be 6 kilowatt. On the 10, it'll be 10. On the 12, it'll be 12. Okay, so you don't get 6 here and another 6 there, unfortunately. And a warning that we need to take note of: if the AC couple or smart load function is enabled, then the generator must not be connected to the generator port. That is common sense, but we have to put that disclaimer in our training, right? Okay, so generator remote control. The generator remote control function is available on this machine as it is on our 8, 10, and 12. Underneath the machine here, you will see a dry contact port. It's normally nominated by a green connector block. And we have two relays inside the machine. One is normally open and one is normally closed. So depending on the stop-start function of your selected generator, you would have to look and see if it supports the normally open type or normally closed type relay. Okay, so the generator connection, the generator should be installed on the gen port of the inverter, which is here. If the generator could support remote control feature, then you must use this green dry contact here to make use of the relays inside the machine. And basically, like I mentioned, they're normally open or normally closed type. So there will be an NO, a C, and an NC. So the NO is normally open, the C is the common port, and the NO is the normally open port. And then depending on which relay you want to use, you would just simply use the 2-wire contact inside there. All right, when the generator is turned on, it'll take the load and charge the battery at the same time. Remember that, right? So when choosing the right sized generator for your installation, always make sure that the generator capacity is equal to or greater than the inverter. The maximum that we can take, that we can select on our settings is a 7.3, I think it is a 7.4 kilowatt generator for the LXP6. You can obviously use bigger generators than that, but the settings, from the settings point of view, we can only select that size as the biggest particular size. And the reason why we need that is we use it for the logic, because the inverter needs to divert power. First of all, it needs to take power from the generator, supply the EPS loads, as well as charge the battery. And then on the settings page, you can also set the generator charge capacity. In other words, you can limit the capacity of the generator charging if you suspect or expect that you have a higher EPS load. Okay. All right, so the AC coupling, remember what I said earlier, is if you already have, here we can see on the graphic or on the drawing, you can see that there's an existing solar system. It could be a Sunny Boy, it could be any grid-tied inverter, right? And it already has some solar panels. Here we have strings of solar panels. So the AC output of the existing solar system will come in to the gen port, right? And then on the settings page, we're going to go and enable AC coupling. What the inverter will then know is that there is an AC supply fitted to the gen port, and particularly it would expect it to come from a grid-tied inverter. All right, and then here you have your backup or your EPS panel or your EPS DB, and that is connected to the load side. And then here you have your non-essential load, which are connected directly to the utility side, right? You'll see here that we share the common earth, and we've bonded it to the machine, to the earth in the non-essential side as well. I mean, essential side as well as the non-essential side. All right, so if you need the existing solar system to work regardless if the utility grid is on or not, it should be connected to the generator port. Basically, if you have an existing solar system and you want it to work whether the grid is on or off, because remember, grid-tied inverters, when the grid goes off, they go off, right? So you're going to connect it to our to the generator port, and you're going to enable the AC coupling. And then once the AC couple functions, the generator must not be installed on the gen port. Obviously, that's common sense, but we have to put that disclaimer in. And then another point to remember is that the maximum input power suggestion for a grid-tied inverter cannot exceed the capacity of the inverter. In other words, so for 6 kilowatt, our maximum input is 8 kilowatts. And obviously, for bigger machines, you're going to be using bigger power than that. Remember that our machine has what's called frequency shifting. It's got frequency shifting signaling for your grid-tied inverter. So it means that when the batteries, if you're using it for battery charging, then once the batteries are fully charged, and there is we need to either slow down or start up the function of the existing inverter. We can do that via frequency shifting. Your inverter supports frequency shifting, okay? And by doing that, you have to make sure that the frequency shifting is enabled on the grid-tied inverter. All right, so let's have a look at our working modes now. We're going to look at operating our machine without any battery, okay? Remember, in quite a few of our previous seminars, I spoke to you about the capacity of the SNA6, the new gen LXP, as well as any one of the LXPs in our range. We can operate the machine without battery. It's a great feature to have because it simply means that you can now sell a machine into a scenario where the customer doesn't have the budget to put in batteries, but they do want to make use of the benefit of having solar to supplement or benefit their loads. All right, so in this particular scenario here, in scenario A, we have solar panels connected to the inverter. There is no battery connected, and there is also no loads connected to the EPS side. So power is coming in from the solar panels. It gets rectified inside the inverter. It comes out as an AC power, and then it goes directly to the connected load here, okay? You can also export, if you are allowed to export, you are allowed to export that, but we're going to go through it in a second. Or alternatively, what you can do is in scenario B, you can have your solar panels connected. There is no battery, but you do have small loads connected to the EPS side, and then your bulk loads are connected to the non-essential side, and then obviously there's grid. Now remember that the minute grid goes off, the circuit is broken around about here, and only power will be supplied to these loads. However, we also recommend that regardless of how big your PV array is, you might have 6 or 8, 7 or 8 kilowatts of PV here. It doesn't mean that you can confidently connect those size loads, because the power that is coming in will be dependent on how much PV power is generated, and the reaction time of PV is a lot slower than what we can get from battery power in an off-grid situation. We always recommend that you keep these loads to a minimum if you're going to be running without battery, because as the sun sets and the power is cut here, obviously the system in an off-grid situation will shut down, and it'll only restart again when the PV power comes on. So just be mindful of that for whatever load you have connected here. Okay, you've got to keep the loads low, and preferably the reactive power has got to be as clean as possible. Okay, so let's have a look at scenario 1. We've got a system without battery installation. So it's typically this is what the display screen looks like on the new N6. It's a screen that looks like this. So you're going to, it has 4 buttons on the front, and you can navigate through the screen. The very first thing you're going to do is you're going to set under the common settings, you're going to make sure that you've told it what PV is coming in here. Unfortunately, here we've got no PV, but you're obviously going to select PV1 only or PV2 only, or you're going to select one of these on the menu to put in here. You can also select your start PV voltage. And here for lithium battery type, you're going to select no battery. So you'll cycle through it until it says no battery, and you're going to select that there. And then under the application tab here, you're going to go down and set your output power to 230 volts, 50 hertz, or if you in an area where you're using 60 hertz, and you're obviously going to change that to 60 hertz. And you're going to select this here. You're going to check this box here where it says PV grid off. What this means is that you want power output from PV with the grid off, right? If you don't check that, when the grid goes off, the output power will go off as well without battery present on the installation. All right, and then you're going to check this box here where it says power backup. You're going to enable that because you want power to come out of the EPS socket when the grid falls away. Okay. Right. So let's have a look at the different scenarios. In scenario 1, remember that there is no battery here, right? So that's why we've got a cross here. Grid cell back is allowed. The solar input will come in here. It's going to go through our rectifier. It gets converted to AC. It's going to supply the house load first, and the remaining power will be exported to grid via the CT if you have enabled grid sellback. Okay, then scenario 1, no battery. We've got 6 kilowatts of PV. It comes in, it gets rectified, inverted to 6 kilowatts of AC. We have 3 going to load. And remember that this always follows the profile of the load. If the load is at 3 kilowatts, it stays at 3. If the load drops to 2, it will drop to 2. And then obviously the excess will be exported to the grid, depending on what you have selected to be allowed to be exported. Scenario 2, we also have no battery, but the grid sellback is not allowed. Okay, here it is allowed, here it's not allowed. The solar input will track the power based on the house load consumption. So here you've got your PV coming in, gets rectified, inverted to AC, it comes out, it's not allowed to export there, it'll go down and it'll supply the load, and the load profile will, the PV profile will follow the load profile, all right? Just remember that in a grid on situation, you're going to have the power supplied here first, and if the load exceeds the PV capacity or the reactive power is higher than what the PV can supply, then it will obviously bring in additional power here. And in this particular scenario here, we also have no battery. We've got no grid, but we also have, just have PV. So what's going to happen is the power will come in through this track here and go to the EPS output. Okay, here it's going via the grid output. Here it's going via the EPS output. And remember that we said You've got to keep these loads to a minimum and try and keep the apparent power as clean as possible, so that the reaction time for the PV can track it quite accurately. If not, then we will get an EPS overload and the machine will go into standby mode until that is rectified. Okay, if grid export is not allowed, then set the grid here. Do not do this, set this to 0, and you should be golden. All right, so in scenario 2, we're looking at a system with battery installation. So here we have exactly the same graphic, but only the difference is we've added a little HANA power gem to the graphic. Now we have two sources of DC input. We have our PV coming in. We also have battery coming in. We have our EPS load here, or our backup load connected here, and then we have our non-essential loads connected here, and then obviously grid. In a self-consumption mode, default power is always solar, battery, and then utility. In battery backup mode, which is, for instance, in the absence of grid, whether either the grid is off or you've gone into off-grid mode, then the default power up sequence will always be solar, utility, and then battery. And then time of use mode, this we use for areas where they have different tariffs, and you want to charge or discharge your battery depending on the price of the electricity. In other words, when the tariffs are high, you're going to discharge your battery, and when the tariffs are low, you will charge it up. Okay. In this particular case here, you can have a look at the screen in self-consumption mode. What we're going to do here is that if the compatible lithium battery is installed, like a HANA, Dynas, Pylon, any one of the batteries that are on our list, we're going to select our battery discharge control as SOC. We're going to set the on-grid cutoff to a value that you're comfortable with, and then the off-grid cutoff has to be what the manufacturer recommends. Okay, so with Pylon, it's 5%, with HANA, it's 5 or 10%. I know Dynas is 15. So when the grid is on and you're using battery, it will always terminate using the battery at this level here at the on-grid value. And if the grid goes off, or if there's no grid available, it disregards this SOC here, and it will always discharge the battery to this value here. All right, and then you can also set your discharge current limits, if it's one battery or two batteries, whatever the case may be. But remember that your discharge current limit, 125 amps is quite big, okay? So 125 amps at 52 is 6.5 kilowatts. So you can limit the discharge current here. That will be limited to the size of your inverter, as well as the rated breaker and cabling size, okay? And then your system discharge power rate will also be set here. On the discharge tab, you're going to, for instance, if you want to make sure that you are not using grid power, charge your batteries, you're going to disable your AC charging, and you're also going to set your forced discharge to off. In this particular scenario here, what's going to happen is that the inverter, which is this one here, you're going to, hang on, let's see if we can go back to the previous one. No. All right, so here we're having a look at the self-consumption mode in scenario 1. When the generated PV power is greater than the total needs of the battery, only if then, in other words, it's going to charge the battery first, then it will go to buying the house load, and then it will go to exporting to the grid, right? This is in scenario 1, when the generated PV power is greater than the total needs of the battery charging and the load consumption, which is here, and the surplus power will be exported to the grid. In scenario 2, when the generated solar power is not enough, then the battery will assist with the loads like this. And if these two combined are not enough, then in this scenario here, it will bring in additional power, okay? So the three particular scenarios that we have here is that the PV is enough to charge the battery and provide loads with excess to go to grid. Here we have sufficient, between these two, we have combined, we have sufficient PV and battery power to be inverted into the house load power. Nothing comes in from grid. Alternatively, if these two are not sufficient, then it'll bring in the excess from the utility. All right, in scenario 2, we're going to look at battery backup mode. So if the solar power is not enough for the battery charge, then you could set it to AC charge, right? So in other words, if you don't have enough PV to charge your battery, or if you want to make sure that you are charging your battery at certain times of the day to make sure that you have some reserve power in your battery, then you can select the charge and end times here. We've put 3 specific time slots in here. And the reason we've done that is so that you can choose different times during the day when the tariffs are lower, charge the battery. So you can make use of 3 different time slots. Always remember that any gap in these times, for instance, if we set this one here to 6 a.m. and 8 a.m. and then 12 p.m. to 2 p.m. and 6 p.m. to 8 p.m., the gap in between these settings, the inverter will determine these are allowed times to discharge the battery. And it's going to discharge the battery according to the end of discharge for on-grid, all right? In a couple of slides ago, remember we looked at on-grid end of discharge and off-grid end of discharge. So if there are gaps in this time here, any gaps in here, it will see it as an opportunity to discharge the battery until it gets to the on-grid end of discharge. If you disable your AC charge, right, but you set your charge first enabled for 24 hours, it's going to use the PV to charge the batteries, but it will also not discharge the battery during these gaps. Quite a handy thing to have. So here, if you set it from 00 to 2359 with a power limit, then it will make sure that the battery is charged first with PV, and it also will not use AC to charge the battery, even though this is disabled. Okay, so here you can set your charge first power. Remember that on the 6 kilowatt inverter, you can put up a maximum of 8 kilowatts of PV. So you can actually determine how much of the PV power must be dedicated to charging the battery. And here you can also set at which SOC the charging will stop, or at which voltage the charging will stop. All right, so these are pretty handy and cool features that have been added to this machine to give you the flexibility to be able to set up your client's installation according to their requirements or to fit their load profile. Right, so in battery backup mode, the default power up sequence will always be solar, then utility, then battery. So it's solar first, then PV, then battery last. Right, so let's have a look at in scenario 1, when the generated PV power is greater than the combined requirement of the battery requirement and the load, then we're going to have PV going to battery, to inverter, to load, and then exported. When the PV power falls below the charge power limit, what happens then is that the PV is dedicated to battery charging like this, and the grid will supply the load. See? So here, PV is going directly to charging the battery, and the grid is taking the load. Or alternatively, when the grid power is out, here we have either load shedding or an outage in the grid, then you will have the battery discharging and the PV discharging to the EPS side, okay? So remember that you have these 3 scenarios that you can work around in battery backup mode. All right, so a system with solar power and battery installation, and we want to go for time of use. In a particular case, we want to charge the battery during the time period when the electricity price is low, and we want to discharge the battery during the time period when the battery electricity charge from the grid is high. All right, so then we're looking at grid tariff charges. What we're going to do here is we're going to enable the forced discharge. Here you see it here, and you will also see it on your settings page. There's a dedicated section to charge the battery. It's called forced discharge. And I'm going to explain something to you very briefly. I'm just going to see if I can bring up a particular machine. Give me a second. I'm going to call up one so that we can have a look at it. And then I'm going to give you we'll have a look at the settings page. Just bear with me 1 second. Let me share with you. You guys can see the settings page now. All right, so here we have a typical settings page of an LXP6. All right, so if you have a look here under the discharge settings, we have a forced discharge section here. Now, this forced discharge section, you've got to enable it. And when you put the forced discharge times in here, be very mindful of the fact that when you force discharge the battery, it will force discharge the battery to the EPS load, to the non-essential side, and it'll push battery power to grid if you have grid sellback enabled. So grid sellback is enabled and you enable forced discharge, it will force discharge the battery, stored power to grid. And this is how you can sell energy that you've either harvested from your PV panels or energy that you've bought at a cheaper rate. You can sell it back to the utility by enabling this feature here. The disclaimer that I've got to mention to you is that you have to be registered with your utility supply company when you are doing that, okay? So please make sure that you're always going to be allowed to do that before you do that. All right, so let's go back to this one. All right, so oh, okay, great. So let's go to is that the right one? Okay. Apologies about that. Is it the all right, you'll be back on screen now. All right, so just remember that time of use mode, if you're going to be using that forced discharge, then it's going to export battery power to the grid, okay? All right, so let's have a look at the two scenarios in time of use mode. When the battery is charged, when the grid electricity price is low, all right? In this scenario, the tariff charge is quite low. So PV is charging the battery. Your utility is also coming in, applying the load and assisting with charging the battery at the same time. The battery discharge power in scenario 2 is used to compensate the load when the solar power is not sufficient, or the sell back and the battery power is not sufficient, or sell back the battery power when the grid price is high. So in this case here, the tariffs are high, so you can sell back your power. So the PV will come in, compensate load. The battery will also come in to assist, and any excess power between these two will be sold the grid. All right, so in this particular scenario here, the house load will always be met first before any excess power combined from the battery and the PV will be sold to the utility. All right, so retrofitting for an existing system. So remember, very earlier on, we spoke about the so I just want to minimize this. We spoke about the AC coupling function. So here you have an existing grid-tied inverter like a Sunny Boy or something like that. and retrofitting the on-grid system, a hybrid storage system. It's called AC coupling. Or you can enlarge your solar system to meet the increasing power consumption demand from scenario A to scenario B. But just remember that when you enable this function, that the generator is not allowed to be used. Okay, so in the first situation here, you have your grid inverter coming in onto the AC coupling port. You've got a battery, it goes to load, and also you are supplying either exporting to grid or you are supplying a non-essential. On this particular setup here, the difference between these two pages, the Gen 6 has got its own PV input as well. So you've got now two PV arrays. You've got your PV coming in, maybe a maximum of 8 kilowatts coming in there, as well as you've got 8 kilowatts coming in there. This is supplying all of the load. And the handy thing in this particular situation is that you can sell a lot of power back to either using first on your non-essential side or to sell to the grid side. Your utility. Okay. When the grid power is on and you need AC coupling power to take the loads with grid power together, the grid sell back function could be set to on. All right, so here you have got to hit the on position, and you've also got to specifically say how many kilowatts you want to sell back to the grid. All right, once you've reached that limit, the machine will it will initiate the frequency shifting to slow down the power generation of your grid-tied inverter. All right. If your grid sellback power is not allowed, in other words, if you are not entitled to sell back power to grid, so your grid-tied inverter is only going to supply, assist with battery charging and supply your essential and non-essential loads, then you've got to select go to off-grid mode to be enabled, because grid sellback function must be on for the AC coupling to work. If you want the AC coupling to work, but you don't want to sell to grid, then you've got to select the go to off-grid feature, which we have on our page, and I'll show it to you a little bit later. The AC coupling start and end SOC voltage limit will only take effect in the power backup mode. And remember, on a previous one where you've got the power backup mode enabled, so remember that this particular stop and start AC coupling SOC will only take effect in the when power backup mode is enabled, right? In other words, when the inverter is putting out power when the grid is on or off. And frequency shifting will only work when the AC coupling input power is higher than the input demand. So frequency, the frequency response mode must be enabled on your grid-tied inverter. And essentially, I mean, for those of you who don't understand how this works, the inverter can trigger your grid-tied inverter to stop or start or slow down production by shifting the frequency, in other words, the hertz of the 230 volts on that port, to make sure that this inverter will stop or start. That's how the grid controls your grid-tied inverter. Okay, retrofitting, here we're having a look at the different charge modes. So we can have the charge first mode, or we can have the self-consumption mode. So in this particular case, you've got your 6 kilowatt inverter, it's got its own array of PV and a battery, and then you've got a grid-tied inverter coupled in on the AC side. Remember, see, this goes in on the AC side. In the charge first mode, the AC coupling will provide its power to the inverter. The PV coming into the 6 kilowatt will also be converted to DC, and it'll charge the battery, right? And the house load will be taken care of by the grid in charge first mode. So remember, you can set those charge first times. You can also set at which point this SOC cutoff is, and then it'll go back to the self-consumption mode. So you can have a dedicated time for charging first, and then you can have, after that, it'll go to self-consumption mode, where the PV will charge the battery. This goes to take the utility or export to grid, or alternatively assist with charging the battery. Right, back up with generator. So here we have two scenarios, A and B. We've got our 6 kilowatt with PV coming in. We've got a battery. We've got the grid, non-essentials, essentials, and we've got a generator coming in as well. And in this particular case, we have exactly the same as that, but we have no generator coming in. So there's all the loads are now on the EPS side. Okay, so for grid stability, sometimes it means that you've got to add a generator. And for this, we have a few logic examples where you can simply use it. So on the settings page, either in the inverter itself on the screen here, you can see for the charge, we can set the generator charging, or the user interface on the web portal. You can also do the same thing. It's obviously much more user friendly. What you can do is here, you're either going to set it according to the battery that you're using. So you're either going to go with SOC or you're going to go with voltage, depending on which battery you've chosen. And if your generator supports the dry contact connection for auto start and stop, then you can use it. Just remember that the generator dry contact won't be activated when we are using AC coupling or smart load function, or alternatively if the grid is on. There have been customers that have asked us, can I not use the dry contacts to run a separate relay? So for instance, I want to, when my battery SOC gets to a certain level, then I want to use the dry contact to trigger a relay to switch my geyser on and off. So the answer is no, because if the grid inverter detects that the utility or the grid power is on, then the dry contact for the gen port doesn't work. Or if you're using it for AC coupling or for smart load, it also doesn't work. All right, so here you're going to change your control to C, and then here for the generator, you're going to determine what is the charge current, right, here. And you have to remember that this current is in DC, not AC, okay? So here it wants to know what is the battery charge current limit in amps DC. See the DC? So in other words, if you want your battery to charge at 1 kilowatt, so you're going to take 1,000, you're going to divide it by your voltage, which is 56 volts. So that's only 17 amps DC. All right. And then you tell it what size generator you've got. You tell it when it must start charging the battery and when it must stop charging the battery. And remember that this value needs to fall below 1% below the start and 1% above the stop for the trigger to stop and start. Okay, so let's have a look at the scenarios here. We've got a generator start function, start condition when the utility fails. In other words, here when we go to load shedding or there's maintenance on the grid and the grid falls away and the generator has a stop-start function, then it will look at those cutoff settings. So the generator won't start immediately. It's first going to wait until these values here are achieved, remember? So the generator will only start when you have set this value, and it'll only stop when you set this value, regardless of whether you invert your generator as an auto start or not. It's only going to start taking battery charging from this time. Even though you've started the generator when the grid falls away, the generator will take load like this, and it will only start charging the battery when the start and stop SOC, start SOC is achieved, and it will stop charging the battery when the stop SOC value is achieved. In this particular scenario here, we've got PV assisting with the charging, and then you've got the generator. So in this case here, the PV will go like this, to there, and the generator will go that route to charge battery, and it'll take load. Okay, we do have a generator boost function available, and that is because we fitted a CT here. We can assist the PV, if it's available, can assist to first charge the batteries and with taking load, but you've got to enable the gen boost function on the settings page. All right, and then on the in this particular scenario here, when the grid utility power is not available and the battery discharge is allowed and the generator stops. So here it's charging and here it's not. In other words, this breaker is open, this one is open, and for load shedding, and now you have combination doing this here. And obviously when the SOC here gets too low or this falls away, then it will allow power to come in and supplement taking the load as well as charging the battery. All right, guys, thank you very much for your time. We're going to go now to the questions and answers. I'm going to go to the chat to see if there are any guys that have answered. I think we've got quite a few questions that have been asked here, so let's just quickly go to that. Just remember that this particular training session has been recorded. I will stop the recording after the questions have been answered, and then Kathy at head office, she will make sure that this particular recording goes to our YouTube channel, and you can download it at any time. All right, so can you share to me what brand of CT compatible with this inverter type? So first of all, the CTs, we supply a CT with the machine. So you'll obviously use the CT that we supply, but if you have your own CT, the CT just has to be, the sampling ratio has to be 1,000 to 1. That is the sampling ratio. And our machines also take a smart meter, in other words, where you can use a smart meter in the CT port. The question is, if I want to set my inverter to be zero export system, must I add a new CT or the inverter have an internal CT like the SNI? No. Good question. This inverter obviously has internal CT, but it also has an external CT, which is supplied as a standard with the machine. So and remember I said right in the beginning that the CT clamp on this machine is critical to the function of this machine, especially for the logic as well as the infographic or the display on the machine. So it's very important that you fit the CT, regardless of whether you want to export or not. It's very important that you fit the CT. My inverter is exporting to the grid. How do I stop it? Because it's tripping all the building. Okay. I see that somebody's asking you there, so it looks like they could be. Yeah, the question that the guys asked is related to an SNA, so it looks like it's been answered already. Can you share to me what is the new feature of the Gen series that the SNA type is different? And okay, so that's also a very good question. Our SNA 6 compared to the Gen 6. The SNA 6 is our entry-level machine. It's an air-cooled machine. The fans suck air from the outside and blows it across and inside the internals of the machine for cooling. The machine itself on the SNA, the chassis of the machine is mild steel. It's powder coated, and it only comes with a 3-year warranty. The Gen 6 is a totally different design altogether, even though they are both rated for 6 kilowatts. The Gen 6 is an IP65 rated machine, whereas the SNA 6 is only an IP20. The Gen 6 is made out of pressed aluminium. The chassis is aluminium, and we do not use any mild steel or any corrosive or any metals in the machine that is standard corrosive. So we are using stainless steel, we're using alloys, and we're using aluminium to construct this machine. The Gen 6 also has 2 cooling fans, but the cooling fans are situated on the outside of the machine and they blow air over the heatsink. And you will also see that on the back of the machine. I'm going to see if I can go to the very first slide, which is here. Can you guys see the screen? Right, so here you can see the bottom of the machine, and here we have our induction coils, which are housed inside these sealed units here, and they also get cooling fins on them. And at the back here, we have the big heatsink, and there you can see one small section of a fan sticking up, and there's the other one. With the SNA, the fans are into the machine. The induction coils are exposed, and it draws air through the machine. So those are the 2 major differences on the machine between the SNA and the LXP. The SNA doesn't have all of these fancy connections at the bottom. It doesn't have a DC isolator for the PV. It doesn't have MC4 connectors for the PV. It doesn't have these external battery connection points as well as these plugs. So ergonomically and it's a totally different design altogether. With the SNA, you only get a 3-year warranty, whereas with the LXP, you get a 5-year warranty as standard if you're using it with any other battery. But when you use it with a LuxPower or a Hino battery, you get an automatic 10-year warranty. which we cannot offer you on the SNA. So those are the only two, those are the meaningful differences that we can point out to you. Okay, guys, so once again, I want to say thank you very much for joining today. It really means a lot to us that we are able to host training sessions like this. And I just want to say thank you to each and every one of you who are installers of our product. If you're an end user, we thank you as well. Without your support, without you guys currently and continuously recommending and selling our product, it wouldn't be the success that it is. And then obviously there's a big shout out to our guys in Zambia. It's a brand new market for us. You guys are doing well. I will be coming out to Zambia next week or the week after to do some training with our distributor there. So I'm looking forward to meeting a lot of you. I'll be there for a couple of days. So please check in with the distributor in Zambia, in Lusaka, to make sure that you find out exactly when the presentation will be taking place. And I'm looking forward to meeting you guys. So once again, guys, thank you very much. Just remember to go to our YouTube channel. You'll find all of our training videos there. You can go to our Facebook page, to our Instagram page. You can like and subscribe to be kept up to date with what we're doing. If you want to see the shows that we are presenting around the world, remember a brand that has grown phenomenally now. We're represented on all 7 continents of the world. We have distributors in South America, North America, obviously in Africa, in Europe, in Asia, and in Australia. And without you guys, this brand could never have grown to what it is today. So we want to thank you once again. And like I said, follow us on Facebook, follow us on Instagram, and you'll be kept up to date with what we're doing, especially with our new product launches for the guys in Africa. What you can be looking forward to is we are going to be rolling out this particular machine that we've just highlighted today, which is Gen 6. We're also rolling out the new Gen 10, which is it's the 10 kilowatt LXP, but it's a totally different looking machine. It's a different ergonomic design. And then we're also bringing and launching the Trip 20, which is the 3-phase 20 kilowatt. It's a high voltage DC machine. And coming soon, I can tell you, because we already have we've seen the sample, is we've got the SNA 12 kilowatt, which is currently under development. So it's a 12 kilowatt SNA, the big daddy. So if you think the SNA 5 was cool and the SNA 6 even cooler, wait until you see the SNA 12. So yeah, it's coming. We're pretty excited about it, and we're going to launch it in Africa next year. Okay, so I see somebody's asking for our email address. Go to our website. We've got websites. So we've got our international website is www.luxpowertek.com. I'll type it in the message. So it's luxpowertek.com. And then we also have our South African or the African website, which is luxpowertek.co.za. Those are the 2 websites that are currently running our product. Do not go to luxpower.co.za. That site doesn't belong to us. It's somebody that's illegally squatting on that domain, and we are dealing with that at the moment. Yeah, so if you want to see our product, you want to see anything new, go to our website, go to Facebook, go to Instagram, like and subscribe, and we can't wait to see you guys again soon. Thank you very much for attending, and hope to see you guys soon.